Section 7.5 is going to get more in depth with the probability for our college algebra. Let's define some vocabulary first. When they say an experiment, they're referring to a random experiment. Refers to a random, and we always call it an experiment, but it's a random set of events. So, for instance, you might be flipping a coin, a fair coin, rolling dice, just tallying up what happens naturally. The sample space is a set of all possible outcomes. And then the event is I think I wrote down the wrong definition from your book, but it's how many things actually happen. So, in other words, if I'm rolling 2 die, that's not a good example. If I'm flipping 2 coins, there are 2 events in that problem. Sorry, bad job. Let me get this out of here. Maybe. Here we go. Example 1, a nickel and a dime are tossed. How will we identify a sample space for this experiment? So, I'm going to do a tree diagram. And I'm going to start with the first coin, which is the nickel. So the nickel could either land on heads or tails. And then after that, we're going to toss a dime. So for the dime, again, he could land on heads or tails. He could land on heads or tails. So if I look at the end of my tree diagram, there are 4 different outcomes. There's 2 events, but 4 different outcomes that are happening. But the way we notate the outcome is really important. So for instance, this first branch up here, the nickel landed on heads and the dime landed on heads. So I might notate that as heads with a subscript of N for nickel and heads with a subscript of D for dime. The second branch is heads for the nickel, tails for the dime. And then my third branch is tails for the nickel, heads for the dime. And then my fourth branch is tails for the nickel and tails for the dime. So there's my 4 outcomes listed out. Then the question is, what is the sample space if we are only interested in landing on heads? So when I look at my 4 outcomes, the sample space, meaning how many times did something land on heads? There's either 0 in this case, or there could be 1 heads landing, or there could be 2 in this case. Kind of weird notation. We'll get used to it. Let's maybe, whoops. Let me bring this down a little bit. Whoops, not that. Try again. Bring it down. There we go. We have recording the boy-girl composition of a family with 2 children. So what's a sample space if the sex is equally likely for birth order? So my first child could be a boy or a girl, equally likely. And then when the second child comes around, could be a boy or a girl, coming off of each branch. So to dictate what happens here off each of these branches, I'm just going to write the letters in order. So my first outcome would be boy, then boy. My second outcome would be boy, then girl. Third outcome could be girl, then boy. And fourth outcome could be girl, girl. So 4 different possible outcomes for these 2 children that I'm supposedly having. And what is the sample space if we're only interested in how many girls are in the family? So there's either 0 girls, there could also be just 1 girl, and there could be up to 2 girls. All right, consider an experiment of rolling 2 die. So making a sample space of this is kind of annoying. On your formula sheet from the last chapter, we have a little sample space of the die on there for you. So when you take your test, you don't have to write this out every time. So I could have the die landing on 1 and 1. Could be 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Could also land on 2, 1, 2, 2, 2, 3, 2, 4, whoops, 4, 2, 5, and 2, 6. 3, 1, 3, 2, 3, 3, you get the idea, but we're just going to write it out once for excess, and then we'll never have to write it again, hopefully. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, whoops, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So the question is, what is the probability, or sorry, what is the event that corresponds to each of the following outcomes? So when I say what is the event, we're actually going to write out the outcome itself in set notation. A sum of 7 turns up. So that could be as simple as a 1, 6. That could also be a 2, 5, a 3, 4, a 4, 3, a 5, 2, which is different from a 2, 5 because of the 2 die, and then also a 6, 1. So there's 1, 2, 3, 4, 5, 6 different times that a 7 sum showed up. Sum of 11, the outcome could have been a 5, 6 or a 6, 5. Again, those are 2 different outcomes, believe it or not. A sum of less than 4. So that would be a sum of 3 or a 2 and you can't get a 1. So the options are 1, 1, 1, 2, and 2, 1. Some of them aren't too bad to find. A sum of more than 12. That is the empty set because there's no way you can roll 2 die and get a sum of more than 12 because 6 is the highest number. So this is a not possible or an empty set. A sum of less than 5 would be, oh goodness, 4, 3, 2, 1. So start with the easy, oh, can't get a 1 Abruzzo. Start with the easy one too. 1, 1, and then 1, 2, 2, 1, 2, 2, and a 3, 1, and a 1, 3. Did I forget that one? Down here, 1, 3. Okay, a sum that is prime and greater than 7. So the only thing that can happen that's prime and greater than 7 would be a sum of 11. So the only way to get an 11 is 6, 5 or 5, 6. Ooh, okay, let's talk about probability now. Probability referring to example 1, which if I look back in my notes, example 1 was the tossing a nickel and a dime and landing on heads and tails. What's the probability that it's going to land and only give you 1 head? So if I look at my outcome there, that was a 1 out of 4 chance. So, no, I'm sorry, 2 out of 4, Abruzzo. 2 out of 4, which is 1/2, I can count. What's the probability of getting at, oh, that was exactly 1 head, sorry, at least 1 head, meaning that we could have 1 head or 2 heads. And if I count those up, I think I have 3 out of 4. Probability of heads or tails landing is kind of weird. It's 100%, so 1. Probability of getting 3 heads. It cannot happen if you're only tossing 2 points. Example 2 now with the boys and girls, I believe. Probability of having at least 1 girl in the family. So 1 girl or 2 girls would be a winner in this case. That would be a 3 out of 4 outcomes. Probability of having at most 1 girl in the family. Oh, I think I have a typo in this. At most 1 girl means that you could have 0 girls or 1 girl. So if I add that up, it's actually 3 out of 4. Let me fix that on my key. Good thing I caught that. And then find the probability of having 2 children the same sex. So girl, girl, or boy, boy would be 2 out of 4, which of course is 1/2. Example 3 now was the rolling the 2 die. Getting a sum of 7. So if you go back to that diagram and you figure out how many times it added up to 7, that was 6 out of 36 times, which of course we want to reduce to 1/6. A sum of 11 is twice out of 36, so that's 1/18. A sum of less than 4, so a sum of 3 or 2 is what we're looking for, and that's 3 out of 36 times, which is 1/12. I'm sure you guys can count with the best of them, so I'm moving kind of fast. A sum of less than 12. So what I'm going to do is I'm actually going to find a sum of 12, which is 1 time out of 36, and I'm going to find the opposite of that, or the complement to that, which would be 35 out of 36. So only 1 time was it 12, that means everything else was less than 12. No, 35 out of 36, easier than counting them all up. Probability of sum is less than 5. So that would be a sum of 4, 3, or 2. And I think I got 6 out of 36 again. So 1/6. And then probability that it's a prime number greater than 7, I think we decided that was an 11. And there was 2 out of 36 times, which means it's a probability of 1/18. All right, moving along. In drawing 5 cards from a 52 card deck without replacement, what's the probability of getting 5 spades? So If you think about how many spades are in the deck, there's 13 spades in the deck, and I'm going to be drawing 5 of them. Okay, and I'm going to use a combination because simply I don't care what order I draw them in. So out of my 13 spades, I'm going to choose 5 of them. That's my winners, my numerator, but in my denominator, I can select out of the whole deck of cards. So out of 52 cards, I'm just going to choose 5 of them. Yeah, 5. And when I type that on my calculator, which is fine, I get 0.0026. Let's do decimals on these because these come out pretty gross. In drawing 7 cards this time, I don't know why you need 7. I don't know a lot about card games, without replacement again, so I can use a combination or permutation. What's the probability of getting 7 hearts? So if you think about how many hearts are in the deck of cards, there's 13 again. I'm going to choose 7 of them out of all 52 cards, which I'm also choosing 7 for my denominator. And if I type that in, I get a really teeny number, which anyone who actually plays card games knows it's pretty stinking hard to get that many hearts. Alright, it's your intro to probability. There is a book assignment on 7.5, and then there's going to be some follow-up worksheets.